All right, it's time to solve some rational equations here. And we got little Miss Jenny. What's up, Jenny? You ready to solve some rational equations? Heck yeah, she is. She loves it. Okay, so what's nice about solving rational equations is that we can actually get rid of our fractions if you so choose. Now, if you love fractions, you want to keep them, go for it, but I think I'm going to go ahead and try and get rid of them. Okay, so first thing will be factoring, okay, as usual. So I'm going to go ahead and factor that denominator. Now, what multiplies to negative 10 and adds to negative 3? That's going to be negative 5 and positive 2. Oh, would you look at that? It matches the other two. How wonderful. So that's going to be this denominator right there. Now, what I'm going to do is, well, I know what my least common denominator is. It is the x minus 5 and the x plus 2, right? If we were just adding things, we would try and get this one. We'd multiply this one by x plus 2 over x plus 2. We'd multiply this one by x minus 5 over x minus 5 to get them to look like each other, right? And then all three denominators would be the same. But what we can actually do is we can multiply both sides of this equation by that least common denominator. So I'm going to go ahead and pop some parentheses around this, and we're going to multiply it by x minus 5 and x plus 2. And then this whole side here gets multiplied by x minus 5 and x plus 2. So all my numerators get that. Now, there's going to be some cancellations that occur, but I'm going to go ahead and write this all out so we can see everything happening. So the first fraction here is going to be x, and then it'll be x minus 5, x plus 2, and then I will have that all over x minus 5. Then I will have the 3, and then it'll be x minus 5 and x plus 2 over x plus 2. And then lastly, we're going to have 7x multiplied by x minus 5 and x plus 2 divided by x minus 5 and x plus 2. Oh my goodness, that is insane. Next up, we're going to start canceling with our denominators. Now, you might be like, well, bro, there's some addition there. So these are two separate fractions, so we can simplify individually. It's not all one fraction with addition and subtraction in it, which is a no-no when you're canceling. Okay, so I can go ahead and cancel the x minus 5s. I can cancel these x plus 2s, and I can cancel these x minus 5s and x plus 2s. Now, what you're looking there, look at that. All of my denominators are gone. So I've got x times x plus 2 plus 3 times x minus 5 equals 7x. Now, this is just a wonderful single line algebra awesomeness equation, right? Who knows what we're going to get? It could be linear, it could be quadratic. I don't know. I do know. I do know the future. Let's go ahead and get to it. We're going to distribute. So I'll get x squared plus 2x plus 3x minus 15 equals 7x. Well, would you look at that? We've got ourselves a quadratic. I got to set this bad boy equal to 0. So I'm going to have x squared, and then this right here, the 2x and 3x is 5x, but I'm going to subtract 7x, and I'll get negative 2x, and then the minus 15 equals 0. I combine like terms, and I subtracted 7x to the other side. All right. If I have a quadratic, which I wanted to set equal to 0 so that I can factor and solve using the zero product property. So what multiplies to negative 15 and adds to negative 2? Jenny, do you know what multiplies to negative 15 and adds to negative 2? She does. She said that it's going to be a negative 5 and a positive 3. Okay, thank you, Jenny. Thank you. Negative 5 and a positive 3. Well, there we go. Now I'm going to solve this. So I'm going to get x equals 5, and I'm going to get x equals a negative 3. And you might be like, dang, that was a lot of work. I'm glad we're done. We're not done. Okay, we're not done yet. We do need to check and make sure that both of these solutions work in the original problem. The main thing we're looking at is, do we have any denominators that would be 0, thus making it undefined? So we back out of this thing and look back at the original. My denominators are x minus 5, and x plus 2, and same with the other one, right? Those are my no-nos. Well, if I were to plug in 5, I'd be dividing by 0. So I actually have to exclude this one. It is an extraneous solution. But if I plug negative 3 in, I'm going to get negative 8. I'll get negative 1. We're going to be all good with the 3. Jenny, are you not? She's leaving. Okay. So that would be our final answer there. X equals negative 3 would be our answer for this one. The 5 is extraneous, so we do have to remove that and not have that in our final answer. Otherwise, it'd be incorrect. You'd end up losing a point or something like that, pending, on how it's graded. But That is it. One solution for this one. Whew, that was a lot of work.